Welcome to Study Loop.
This is the answer to Chapter 24, problem number 63 from the Smith Organic Chemistry textbook. In this problem, we're asked to devise a synthesis of each of these four compounds, starting from cyclopentanone, benzene, and organic alcohols having less than or equal to 3 carbons. And we can use any required organic or inorganic reagents. Okay, so for A, what we need to do is start from cyclopentanone, as the problem says we must. Okay, and we are going to deprotonate that with LDA. So LDA and THF as always. And then next, we will treat this with this aldehyde and then water. And this aldehyde comes from, so we have to use starting materials that are alcohols with 3 or fewer carbons. And so we can make that aldehyde just by oxidizing propanol. So there we go. That's where that comes from. And then after this reaction, we are actually at our final product. So nice little single step. Okay, so there's part A. Each of these might end up on its own page. Let's see here. Part B, again, we're going to start from cyclopentanone. So there's that. Again, we'll deprotonate with LDA, THF. And then for this one, we will use this. Okay, and so that is going to come from ethanol. We're going to oxidize that ethanol all the way up to acetic acid. So chromium trioxide, sulfuric acid, and water are going to be the oxidation conditions we need to accomplish that. So there's our acetic acid. And then to get the ethyl ester, we'll just use another equivalent of ethanol and some more sulfuric acid. Okay, so that's where that reagent comes from. After the LDA reaction, will be right here. It's always hard to tell where the top of the screen is for some reason. There we go. Okay, so from there, we need to methylate that alpha position. And so in order to do that, this time we'll use sodium methoxide to get to that more hindered position. Remember, LDA would deprotonate it on the wrong side. And we'll use methyl bromide. And methyl bromide is going to come from methanol treated with PBr3. So methanol treated with PBr3 gives us this methyl bromide that we need to use. And so that is going to be our final product here for part B. So there we go. All right. As I said, I think probably these are each going to end up on their own page. So for part C, we are, again, going to be doing an LDA reaction. So LDA, THF. Okay. And then this time, our electrophile is going to be this. Aldehyde. So in order to make that, we're going to start from benzene. And we will methylate the benzene, the Friedel-Crafts. So now we have toluene, and then we will have to do a free radical bromination on that toluene. And then treat it with base. That's going to get us the alcohol there. And then finally, a PCC oxidation will get us that aldehyde. Okay. All right. So after the reaction on the cyclopentanone, will be right here. This will dehydrate. Okay. And so after that, all that we need to do is reduce this. So we'll do a hydrogenation. So again, excess hydrogen gas and palladium catalyst. Gets us to our final product for part C. And then here on the fourth page will be part D. So this is a deceptively long problem. Okay, so this time we're going to start with a Grignard. Okay, so we use methyl magnesium bromide. Followed by a water workup, as always. And methyl magnesium bromide is going to come from methanol. We'll treat the methanol with PBr3 to get the bromide. And then we will treat the bromide that we just made with some magnesium metal to get the Grignard. Okay, so after that Grignard reaction, what we have is this. So we've added the methyl group, and we have the alcohol as well after workup. And now we can effect, we can effect an elimination here. And in order to do that, we'll just use concentrated sulfuric acid. And so that is going to give us the elimination product. So we would get a mixture here, but the major product should be this one. Okay, and so the next thing that we can do here is cleave this. So that's going to be ozone, and then for a workup, we can use dimethyl sulfide, and that is going to cleave the alkene. And so we'll end up with the aldehyde here and the ketone here. And now the last thing that we need to do to get our final product is just going to be an intramolecular aldol. So some base and some water. Should get us here to our product for part D. Okay, so D, C, B, and A. And that's the answer to chapter 24, problem number 63.